Okay, thanks everybody. So I'm here to give an overview of the Works on ARM cluster and to try to sort out what I have done over the past year, which wasn't obvious at the beginning of the year, and to make it look like there's a grand plan for another year of activity. And I'm reasonably confident that a year from now I'll be giving another talk kind of like this that will reverse engineer a year's worth of activity and try to make sense of it. So right now the Works on ARM organization at a glance from a hardware perspective is about 50 projects using a little more than 60 different servers. The project is funded by ARM to provide access to open source projects, to give them access to 64-bit ARM infrastructure. The servers are primarily in our Packett's New Jersey data center. Packet, just for sake of background, is a bare metal hosting provider. We just raised a B round of funding. We have equipment in 18 data centers around the world and infrastructure that lets people spin up bare metal servers in somewhere between 5 and 10 minutes from a start. So the servers that are in this environment are what we call C1.large.arm, but they're Cavium ThunderX1 based hardware. We also have a much smaller number of HiSilicon 1616 based hardware as well, which is the D05 development board that Huawei put together. D05, does that make sense? I haven't actually seen one up close, but I'm told I know from using them that they're nice, although they're hard to find. So the short of it is that there's sufficient hardware to sponsor a number of projects who would not otherwise have access to 64-bit ARM infrastructure to do a variety of things with them. So, let's see next. So the project has a sort of regular weekly structure and a regular monthly structure. Every Friday I write a newsletter which goes out via Twitter primarily just to notify people that it exists. And then there's a mailing list that people can subscribe to that has currently about 200 members that goes out Monday noons. And then on Wednesdays at 4 o'clock Eastern time, I host a call on Zoom, and typically that has a half dozen people or less, but we talk ARM stuff for half an hour or an hour. So that's been the sort of cadence of the week. The cadence of the month is that for ARM, I produce a monthly report that I try to summarize project activity over the span of the month for that. That's my handle on various media. We have stickers, which I will hand out to people afterwards if they're interested. This is our old branding before ARM told us it looked too industrial because it has an ARM on it. And we made this completely unofficially before the project even started. It says my other server is an ARM server, and that has been kind of a hit as well. So the cluster objectives, we want to support open source enablement across a wide variety of projects. We want to find hardware that's otherwise difficult to get at because it's new, or because it's bigger than what people normally have, or because people need access to data center grade services rather than home and lab services. And above all, we want to find, document, and fix bugs that are specific to ARM64, whether those be initially it was like my system doesn't work, and then it was, well, my system works just fine, it's not quite fast enough for what I want it to do, and just sort of systematically go through the software ecosystem, one project after another, whether we're actually supporting it with hardware or not, and get the level of fit and finish and polish and speed up and as high as we can for various ARM projects. So the targets, this is something that sort of evolved over the course of the year. You can't have a project without having a very strong operating system and kernel level effort. Those are always going to be important. If there's problems at the kernel level, it affects everyone. It turns out that compilers and languages and libraries matter a lot, both in terms of correctness and code quality and performance, especially when benchmarked against efforts that have been going for perhaps more years using more optimizations for x86. So we're sort of fighting the battle of getting things to be, finding people who have an interest in and the capability of writing assembly language code to speed up the critical path for some projects. And then over and above just having things work once, we're super interested in CI/CD and build systems, the sort of really not very hardware specific, but very crucial aspect of making sure that builds are repeatable and that you can have a whole system spit out a whole set of artifacts every time there's a change so that they can be tested. The workloads we're looking at, I'm very interested in cloud native workloads, Kubernetes, the container space, everything necessary so that if someone had a Kubernetes cluster that they could run all the code that they would expect to run for that. The telco and networking space is also very interesting. These are sometimes very large projects that expose some of the dependencies in those sorts of worlds on code that might be older and is not changing very fast, even though it doesn't work yet. And then Packet as a whole is very interested in edge computing. Imagine a world where at the base of every cell tower there's a data center, and what that world would need to look like both in terms of software and hardware. So those are the things that inform the efforts. This is the team. I'm the project lead and newsletter writer and systems support and tech support and a whole bunch of other stuff. The other folks are doing this as part of their time at Packet. Packet has about 50 people, so at some point along the way, some ARM support related issue will have hit everyone, but our fleet of servers is about 95% x86 and about 5% ARM. So it's not a whole company effort, it's a part of the company effort for that. The person that you might run into online is Carl Perry, who is in the Works on ARM community Slack channel quite a bit. And then our lead kernel engineer is Scott Burns. Scott was considering coming here, but he doesn't travel out of the country often enough to realize that his driver's license would not get him in the country, so he's at home in Nevada. And that's it in terms of slide presentation. What I'd like to do is sort of quiz folks and discuss with people and talk about their I guess the first thing is like, how many people have access to the cluster right now by show of hands? What's that? Through packet.net. And then how many people, having heard this brief discussion, sounds like something that they would be interested in getting involved in? It doesn't have to be everyone, right? So the biggest challenge I have right now is not lack of projects that are interested. It's getting access to a diversity of enough hardware to address everyone's needs. A lot of people are interested in getting access to the very latest hardware that's often in very short supply. So I'm trying to come up with systematic plans for either time sharing things 2 or 4 weeks at a time. You need access to a Thunder X2 machine. We can give that to you, and then we'll take it back from you. And or work with organizations that work with internal projects that will, instead of providing bare metal as we've been doing for the past year, start to offer people virtual machines. In a lot of cases, a VM is fine if you're just testing stuff. It tends not to be perfect for performance testing because of jitter and variability of performance. Some projects that we've given access to can very easily use an entire machine running full blast all the time. Others have demand that's much more bursty, and so we think that by allocating resources a little more efficiently, we can get more people into the project without having huge more amount of equipment. If anyone has ever tried to buy ARM servers, quantity 2 or quantity 10 or quantity 20, you know, it's kind of hard to do. And so we've got a team of people buying stuff, which has been nice. So I guess I can go a little bit more into different projects that have been enabled through this infrastructure. So go back to this. So from an operating systems level, we have worked with either providing hardware directly to or collaborating with every operating system that you would be likely to use and some that you've not heard of. One of the goals for the project is, to the extent that the resources are available, I want to have a diversity of people using these systems, which sometimes means we're working with people who are sort of at the fringe of development efforts. So the operating systems that we have been working with include Debian and Ubuntu, SUSE and OpenSUSE, Fedora and CentOS and Red Hat and Alpine, but also FreeBSD, because we have a good working relationship with that crew. And folks doing a research operating system called, I don't even know how to pronounce it, Adil, which is Alpine-based with using muscle libc instead of a glibc. So just trying to get enough variety in the whole space to try to hit all the issues that come up. Similarly with languages, we're working with a number of LLVM teams, just got some work underway for GCC, Go, OpenJDK through the Adopt OpenJDK project in the UK, but also the scientific computing language called Julia, which is fairly new in the world, and they were very happy to get an ARM64 machine to port their code to and to get things to work. Often the challenge for portability and for projects is to make sure that people have a CI system that works really well. On ARM right now, the biggest limitation is that the organization's doing CI as a service. So the usual pattern for that is that you would have a CI system running on, you'd have a project on GitHub, and then you'd have a file inside your GitHub repository that would tell the CI system what to do whenever you check something in. Those, right now we've got folks from Shippable and from CodeFresh doing that. We have our sights set on some of the bigger organizations like Travis and Circle, but the long-term ambitious goal is that anyone who has a project who wants to test on ARM should be able to do that without having to go through a lot of friction. For some projects, there's going to be friction because their test needs are very high, right? If you're actually testing every check-in to Go, you need a dedicated machine or maybe more than one. If you're doing a little bit of project development and just need to double check that your binary is built and you didn't do something silly, that doesn't require quite as much infrastructure. So trying to scope out the difference between the projects that need multiple dedicated machines versus just a slice of one has been a challenge over the year. No, it's been really interesting. I just have to say that as a project, trying to port all the software in the world to 64-bit ARM like, everything is in scope, right? There's really nothing that's out of scope for this effort. And so the challenge has been figuring out what to do first. Some of what to do first just was like whoever showed up at the door first got the first dibs on stuff. And then it became very clear that some projects had outsized importance in terms of ecosystem. So we got involved with the people doing the Go compiler fairly early on. The project trajectory of that has gone through like 7, 8, 9, 10. So 5 releases we've been involved in. At the outset, there was an obscure bug in Go that triggered an equally obscure bug in Docker that triggered file system corruption, which wasn't very much fun to sort out. So finding the bug, fixing the bug, getting it into distributions, writing the test cases, because of Go's project life cycle of sending out a release every 6 months, meant that the time delay between the time you found something and the time that it was fixed everywhere seemed like a long time. But once we had that running, and binaries distributed and official status for things, that gave a big uplift to a bunch of container and cloud native workloads. And so we've seen a lot of uptick from that. So the presentation I gave last year at about this time was all about how the process could be made better, but that it wasn't better yet. And now I'd say we're looking at really 2 challenges: optimization for a few cases where things are not perfectly optimized yet, and just going after project diversity, like finding things where people really hadn't thought about doing stuff on ARM64 before, and approaching them and getting them to start things up. So, question from the back?
Enabling all those projects doesn't only take engineering time now, it also takes CI time and runtime on those machines forever.
Right.
Virtually. So how do you plan on scaling these things so that you can sustain that growth?
Forever, right?
Yeah. So
one of the scaling problems is the availability of hardware to purchase in the market. The initial crop of machines that we did this on are all ThunderX1 based that were in Packet's inventory when I started the project. So we've gone from lots of unused inventory, sort of not spare, but like people were not buying it commercially at the price that we had set it for. So we've demonstrated that at some price, free, there's quite a bit of demand. We've also demonstrated that at some price, not free, sort of at list price, there are people with demand for services that are willing to pay for the services that they're getting. Primarily, that's been the niche that has been a clear win is not what anyone really expected at the start, which is using data center grade machines to do 32-bit builds for embedded and IoT devices. So all of our 32-bit machines are completely used up, and we will we're getting more of them, but we're going to use them all up as soon as they come in because there's tremendous demand for build infrastructure. There's commercial demand for build infrastructure. And there's commercial demand for CI infrastructure in general. The people who are running the CI as a service things have figured out the business model so that they understand how to give away some service and sell service on the same platform. So long term, it's not going to be giving away everything, right? It's going to be keeping up with demand for this commercial service and taking the pool of other services and being as efficient as possible as we can with them. So.
What hardware do you currently have available in your data centers?
The ARM hardware in specific?
Yes.
So the specific hardware that has the majority of this is Cavium ThunderX based.
One or two?
What's that?
One or two?
Well, primarily it's ThunderX 1. Those systems have dual sockets, 96 threads, 128 gigabytes of memory, dual Mellanox NICs to give us a 20 gigabyte data path out of the box, and NVMe memory. So they're well equipped for a lot of things. Cavium is not selling ThunderX right now, so what we have is what we have, and we're going to make the best use of that pool of stuff for as long as we have. The other primary machine in the data center is the high silicon, high 1616 based gear, the DO5s. Those chips, I think they're A72 based. They run both 64 and 32-bit code, unlike the Cavium, which is a 64-bit only processor. So those have primarily been allocated towards projects that really can make use of the 32-bit components of stuff. And then in the pipeline is equipment from Socionext that makes a 24-core A53 based server, which is going to be slow compared to the rest of them, but should still be interesting. And part of the goal of the effort is to get interesting stuff as well as, interesting at various levels of things. So that may be not the best build machine, but it might be useful for a bunch of other purposes. We've talked to Ampere about getting some of their gear in place once they have stuff at early quantities. There's some Qualcomm Centriq hardware that
In the pipeline or in the data centers?
in the data centers, but in the pipeline for access, because we had to go through a legal process of understanding who had title to those machines, and Qualcomm lawyers and ARM lawyers and Packet legal going through that. So that's going to be added to the mix as well. So basically, I'm more than willing to entertain conversations with anyone making server-grade hardware to have some, even if it's a small number of systems, come into our labs for evaluation. And if it's possible, the Qualcomm gear for a long time was NDA only, right? There we had a three-way NDA to get access to things. So even those relationships are possible.
So, and a follow-up question. One of the useful applications of bare metal hosting that you provide is the ability to get the whole machine to yourself, which is very useful when you are doing benchmarking and performance measurements. For most of the applications, you don't need huge number of threads. So like 4, 8 cores machines will be enough. Do you have any plans for smaller board hosting?
Yeah, so this plan for smaller is virtualization in some form or another.
But that will not work for bare metal.
Oh, bare metal smaller.
Oh.
So those machines in server class configurations simply don't exist. Like,
Oh, they are bad.
yeah, so you're trying to optimize across cost of machine, equipment size, whatnot, and the people who are building these chips are building them for HPC applications typically, so they're building them with large memories and large CPU counts.
Things like 8-core moonshots, which you have like bunch of boards in one rack.
You don't buy moonshot anymore,
Yeah, the moonshot is no longer commercially sold. So
and you don't want moonshot.
we have a customer has a moonshot in our data center, and
We
it's
have moonshots in our,
yeah.
I'll take them if you don't need them.
you don't want them.
How are we doing for time? Go ahead.
I'm sorry, in the list of OS people you listed, you didn't mention Gen 2. Have any of the Gen 2 people been in touch with you?
We have talked to Gen 2 people. I'd be happy to talk with them more if you have particular people in mind.
Well, because I was bringing Gen 2 up on the Synquacer box that we've got, and I noticed most of the people in the channel seem to be bringing them up on much smaller devices, so they
Right.
probably a few of them would,
Yeah,
would
so
benefit from it.
we engaged with the Gen 2 project on a couple of different aspects, both on x86 and on ARM, and I think they were just not ready for whatever reason to take on another big, to take on the port. Not that they weren't interested.
They have an ARM64 port, so.
Yeah, so that was 6 months ago, so there's entirely possible that they'll get it. Happy to do it.
Okay,
Every additional operating system brings additional value, so. All right? All right, thanks. Oh, go ahead.
One question.
Sure.
If I understood correctly, you said you have lots of people using your machines to build YVR32 for IoT devices.
Yeah.
What hardware are they using?
They're using they're using our hardware to build for their devices.
Yeah, but
So the company that's doing that is Resin, and so Resin has a process by which they can do builds for smaller devices. On our side, we're using the high silicon machines for that.
okay, so you are cross-compiling.
No, they do native 32-bit ARM as well as 64-bit ARM
Okay.
on these, because the chips include both 32 and 64-bit instruction units. So they're doing native builds on a data center-sized machine with a target being another ARM small machine.
Okay,
So-
thanks.
Did you mention all the CI guys that are doing native building, and also Nothing's Ends, also ask people to spread that more?
Yeah, so the CI work that we're doing right now, again, it's shippable and code fresh primarily, and working with Resin for the IoT side of things. We've talked with the folks at Drone who have a port that's just about finished up. Just really trying to push people who have projects that don't need a whole machine but still need CI resources to go to one of those CI as a service infrastructures, and that seems to work out pretty well. Yeah, so you're going to have to tell me about Vexos because you know much more about it than I do.
So they're one new provider, they have an OpenStack API for ARM64 VMs. So if you have a credit card and you want to spin up an ARM64 VM, you don't need a full machine, you can go to Vexos.
Right. And Scaleway also has ARM64 infrastructure as well at very, very small core counts at very small prices. So. Good. All right. I'm being told that it's time to say thank you. I have stickers, so I'll meet you in the back if you want a sticker, and thanks very much.